Lesson 5-5, graphing inequalities into variables. The graph of a linear inequality represents the set of all points that are solutions of the inequality. We've already gone through graphing on a number line. But those were just one variable. With two variables, you're going to be graphing it on a coordinate plane. So the edge of a graph is a boundary. So depending on the inequality, the boundary will either be included in the subset or not. The boundary line divides the coordinate plane into regions called half planes. When the boundary line is included, the solution of the linear inequality is a closed half plane. So if it's included, you're going to use a solid line because it can equal it. So think of like on a number line, you use a filled-in circle because it can include that. Same thing here. You're going to draw a line that's a solid line. When the boundary is not included, it's an open half plane, which means you're going to use a dotted or dashed line. So how do we graph these? So step one, graph the boundary. Use the solid boundary when inequality contains less than or equal to or greater than or equal to. Use a dashed boundary line when it contains less than or greater than. So you're going to use a test point to determine which half plane should be shaded. And a good test point would be, I would just always use 0, 0. So like the origin. The one thing you would not use the origin is if the line goes through the origin. But 0, 0 would be the easiest point. And then shade the half plane. So if 0, 0 makes the true, you would shade the part that has 0, 0 in it. If 0, 0 does not work, then you shade the other half. So an example, it says graph 3x minus 2y is less than 8. There are a couple ways of doing this. One of the easier ways is to use graph the intercepts, but that's if you can find the intercepts with just integers. Here I can't because I can't divide 3 and 8 evenly. So I'm going to solve this into y equals mx plus b and then just graph that line. So the first step would be subtract 3x on both sides, and I would have 2y is less than negative 3x plus 8. Last step is divide by negative 2. I'm going to divide everything by negative 2. Because I'm dividing by a negative number, I need to flip the symbol, and that gives me 3/2 x minus 4. That's the line I'm going to graph on here. My coordinate plane is going to count by 1s. So I go to negative 4, my y-intercept, put a point there, and my slope is a positive 3/2. So if I go up 3 to the right 2, here's my point. I'm going to do another line, another point. Or I could go down 3, 1, 2, 3, to the left 2, 1, 2. And you can see where my line is. Because I have a greater than sign, my line is going to be dashed. And now I have to think, it has to be greater than that line. So we could use a test point. We can use 0, 0. So if I test out 0, 0, if I put 0 in for y and 0 in for x, is this statement true? Does 3/2 times 0 minus 4, is that less than 0? So this would give us negative 4 greater than 0. 0 is greater than negative 4. So this side would be the solution. So I would shade here. Another way of thinking of this would be if I have a vertical line. This is the less than, this is the greater than sign. If I have a horizontal line, greater than is above, less than is below. If I have a diagonal going down or going up from left to right, this is greater than, this is less than. And then if I have a line going down, so a negative slope, then this would be less than, this would be the greater than. So either way, using those, knowing that the line has to be greater than is above the line or to the right of the line, and less than is below the line or to the left, or just choose a test point. Next, solve this one. Here I can do the intercepts because I know they work well together. So if I had 2x is, I'm going to make it equal to 14, and then -7. Let's just put it in slope intercept form because I don't think that'll make it a lot easier. So I'm going to subtract 2x, and now I'm left with -7y is greater than -2x plus 14. Divide everything by -7. Since I divide by a negative number, I flip the symbol. This would be 2/7 x minus 2. So I come to my graph and I put a point at -2. And I have to go up 2 to the right 7. So up 2 to the right 7. Or I can go down 2 to the left 7. There's my line. It's a dashed line because it cannot equal that, so I just have the less than. So I'm going to draw a dashed line. And it says it has to be less than that. It has to be below the line. So below the line would be here. Now I can use a test point. Say I tested 0, 0. So if I put 0 in for y and 0 in for x, this would give us -2. Is 0 less than -2? 0 is not less than -2. So where 0, 0 is, that's not the solution. So the other side is the solution. Example 2, here the inequality with a closed path plane. So that means we're going to use a solid line for these. We're going to do the same thing. So you subtract 3x. 4y is less than or equal to -3x plus 8. Divide everything by 4. And now I have y is less than or equal to a -3/4 x plus 2. So I put a point at +2. And then I have a slope of -3/4. So down 3 to the right 4. Or I can go up 3 to the left 4. And I have a solid line because it can equal anything on that line. And then it says less than that. Less than means it's going to be below. It's going to be below the line. So if everything below here, so I would have shaded down below here. I can use a test point as well. If I test 0, 0, I put 0 here. See if it's true. This side still stays 0. This side would be 2. 0 is less than or equal to 2, so I shaded that part. Next, graph the inequality here. Here I just need to subtract 2x. And I'm left with y is less than -2x minus 4. I put a point at -4. Negative slope of 2, so down 2 to the right 1, or I can go up 2 to the left 1. Here, this one is doesn't have the equal to sign with it, so I would have to have a dashed line involved with it. So a dashed line test point 0, 0. So this would be 0 is less than -4. That is not true. So 0, 0 is not on the side of the solution. So the area that is a solution would be everything here because that is under the line. This next one here, if I subtract x on both sides, I now have -2y is greater than -x minus 4. Divide by -2. I now have y is less than 1/2 x plus 2. I put a point at 2 on the x-axis. Positive slope, so up 1 to the right 2, up 1 to the right 2, or down 1 to the left 2. put also a dashed line. So it cannot equal that. Less than means it goes below the line. So if I shade this, it'd be everything below the line here. Another one, graph this one as half open, half closed. This is actually one where it's going to be closed because it's negative, or it has an equal to part with it. I'm going to subtract x on both sides, and I get 3y is greater than or equal to a negative 6, or negative x minus 6. Divide everything by 3. I would have y is greater than or equal to a negative 1/3 x minus 2. So I put a point at 2, negative 2, go up 1 to the left 3, or I can go down 1 to the right 3. This can equal it. A solid line, and it says it has to be above the line, so it's greater than, so greater than numbers are above. Again, you can use 0, 0 if you want to. 0 is greater than or equal to negative 2, therefore 0, 0 is a solution. Example 3, now we're going to apply it to a word problem. It says Dominique can spend up to $20 to provide a dance squad with drinks after their parade practice. A bottle of water costs 80 cents and a sports drink costs $1.25. How many bottles of water and sports drinks can Dominique buy for the dance squad? So part A, we're going to write and solve the inequality. So we're going to use the bottle of water as our x and the sports drink as our y. So we have 0.8x plus 1.25y, and it says spend up to, so that means it has to be less than or equal to $20. So that would be our inequality. Then we need to solve that inequality. So I'm going to make this equal to y. So I'm going to subtract 0.8x. And now we have 1.25y is less than or equal to negative 0.8x plus 20. And we're going to divide by 1.25. And we have an equation. Y is less than or equal to negative 0.8 divided by 1.25 gives us negative 0.64x, and then 20 divided by 1.25 will give us positive 16. Now to graph this, we're going to plot some points on here. So I'm going to write my equation again. We had y is less than or equal to a negative 0.64x plus 16. We're going to plug those numbers in. If I put 0 in for x and then add 16 to it, that'll give me 16. We could also have negative 0.64 times 10 plus 16 gives us 9.6. And we have negative 0.64 times 15, add 16 to that, and we get 6.4. And if you have 25, so negative 0.64 times 25 plus 16 gives us 0. Now really we just need 2 main points on here. For this one, let's count our axes. We're going to count these by y's. I'm going to count by 4. So this would be 4, 8, 12, 16, 20, 24. And my x's, I'm going to count by 5. So 5, 10, 15, 20, 25, 30. I'm going to plot 0, 16. So 0, 16 is here. I'm going to plot 25, 0, which is here. And that's really as much as I need. I just need 2 points on here. If I wanted to plot the other ones, so 10, 9.6, that'd be roughly here. And then 15 and 6.4 would be roughly here. Now it has the equal to part, so this is a solid line in here. You'll wonder why I didn't use negative numbers, because I can't find a negative of drinks. So it has to be a positive, and your value, money value, is always going to be positive. Then moving on to part C of here, we need to interpret the solution in the context of the situation. So here, one thing I forgot to do is the graphing it. I need to shade in a part that is a solution. So the shading part, everything underneath here would be a solution, but we can't buy part of a sports drink or a bottle of water. So it does have to be whole numbers. So when we interpret this, our solutions, there are many solutions that we can have, but our solutions must be whole numbers. Again, whole numbers are just numbers that are 0 and above. So one possible solution could be I could buy 10 bottles of water and 8 sports drinks, and that would still be in here. So like if I were to go back to here, 10 sports drinks and 8 bottles of water, that would work. I could do 5 sports drinks and 4 bottles of water. So you just can't buy part of something. You can buy whole parts, but as long as it's in the shaded part, that would be your solution. Next, Veronica works at a flower shop that sells roses in large and small bouquets. Large bouquets have 1 dozen roses, while small bouquets use 1/2 dozen roses. There are currently 300 roses in the flower shop's inventory. How many large and small bouquets can Veronica make? Write and graph an inequality that represents the situation at x equal the number of large bouquets and y the number of small bouquets. So the large ones have dozens, so a dozen is 12, so that would be 12x plus 1/2 dozen would be 6, and that would be the small ones, so it would be our y. And they currently have 300 roses in there, so it has to be no more than 300, so that would be less than or equal to 300. That would be our inequality. And if we want to solve this to make it a little bit easier to do, so I could actually do, I'm going to subtract 12x on both sides. And now I have 6y is less than or equal to negative 12x plus 300. Divide by 6. I would have y is less than or equal to negative 2x plus 30. I write that down. Y is less than or equal to negative 2x plus 30. Now create a table of values here. Here, if I put 0 in for x, I end up with 30. If I put 10 in for x, 10 times negative 2 is negative 20. Negative 20 plus 30 is 10. 15, that would give us negative 30 plus 30 is 0. And if you did 25, that would be negative 50. Negative 50 plus 30 would give you a negative 20. This one would not make sense because you can't have negative 20 amount of bouquets. So we're going to use just these numbers that we have here to plot. So our y's are going to be our small bouquets and our x's are going to be our large bouquets. I'm going to count by tens for my x's or my y's. So 10, 20, 30, 40, 50, 60, and I'm going to count by fives for my y's. This would be 5, 10, or my x's, I mean, 5, 10, 15, 20, 25, 30. And then we're just going to plot our points down here. So we have 0, 30, and we got 10, 10, and we have 15, 0. It can equal that, so we're going to use a solid line. Less than that means everything below would be a solution. Now we need to interpret in the context of the situation. So if we go back to our graph, the interpretation part, the numbers have to be whole numbers, number one. Cannot be no more than 30 no more than 30 small bouquets and no more than 15 large bouquets. If we wanted to say like so how many large and how many small bouquets can Veronica make? We can do up to 30 small and up to 15 large ones. So moving on to our next problem. Example 4 here, write an inequality that represents the graph. So here they're going to have us a graph. We need to come up with the inequality for it. So the easiest way for us to do this would be to pick the points that we do know and find the slope of that. So I know what this point would be, and another one I know what this one would be. So assuming that this is counted by ones, we would go up 1, 2, 3, 4, 5. So up 5 to the right, left 1, 2. Since our line is going down, I know that I have a negative slope. So that's a negative 5 halves x. And I need to choose a point in here for my x and y. So if I want to put this in y equals mx plus b format, I would need to find my b. So I'm going to use my slope of negative 5 halves. I'm going to choose a point that's on that line. And I know that this point is 1, 1. So if I put a 1 here and a 1 to my y, this will give us, I'm going to rewrite this as 2 halves. 2 halves is the same as 1, equaling negative 5 halves plus b. Get b by itself, I'm going to add 5 halves to both sides. I now have b equaling 7 halves. And so my equation would be y, but the slope is negative 5 halves x plus 7 halves. And now I have to determine the symbol. I know that it's dashed, so it doesn't have the equal to sign, and it's shaded underneath the line, so that's less than. So I would have a line, or inequality that would be y is less than negative 5 halves x plus 7 halves. Next, write the inequality that represents this graph. Then I'm going to pick 2 points that I know what the points are. And that would be this one and this one here. So we would have this point is negative 6, negative 6. This would be negative 4 and negative 2. So if I go, so they're counted by 2 is going up. So this would be 2, 4. So a rise of 4 and a run of 2. So that will give us a slope of 2. It's positive because it's going up from left to right. So I need to choose our points to find my b. So I'm going to choose negative 4, negative 2. So this is negative 8 plus b equals negative 2. I add 8 to both sides. B is going to equal 6. Now, if we used that point, just thinking this back through again, if I look back here, that's exactly not through that center like it is for this point here. So this one's a little bit off. So if we use this, then you would have an equation of y is greater than or equal to 2x plus 6. if we didn't use that one, if we use this point here, which this would be 7, 0, then we would have a different equation. So I think that would probably be more accurate than what we have here, because that would mean that this would have to cross at 6, and it doesn't cross the y-axis at 6. So that would not be the correct answer there. So let's find the slope. So we got -6, and then 7, 0. So we have 0 minus a -6 all over. Actually, this is not 7, 0. This is 0, 7. So we have 7 minus a -6 all over 0 minus a -6, which will make this 13/6. And then I'll choose a point. I'm going to choose this point here. So my y is 7, when my slope is 13/6 times my x, which is 0, plus b. I would have b equaling 7. So my equation would be y, and it's greater than the line, so above the line, so greater than or equal to 13/6 x plus 7. That would be more accurate than the one we had because it shows that it crosses the y-axis at 7. And our very last question, write a linear inequality for this graph. Again, I need to find 2 points. I can choose this point here, and another point would be this one here. So this is up 1, 2, 3, 4, 5, 6, across 1, 2. So rise over run will give us a slope of 3. I'm going to use this point, which is 1, 2. When y is 2, slope is 3, my x is 1, find our b. It's going to be 3 plus b equals 2. Subtract 3 on both sides. B would equal -1. And if we look here, b is -1. So we would have y. It's shaded above the line, so that's greater than. It's a solid line, so it's equal to our slope of 3x minus 1. That's our lesson today on graphing inequalities into variables.